Hello everyone. Today let us discuss the topic measurement of length. Measurement of length. We have seen in our earlier video the different types of units. In that different types of units, in the main basic units, we have seen meter, that is the unit for the length. Now, meter is the unit for the length. Length is measured in meters, but we have different types of lengths. There are a lot of lengths which we have to measure. Distance between two cities is measured in kilometers, and distance between various countries is measured in kilometers. But there is also very small length which we have to measure, that is distance between atoms. Not only distance between atoms, but we also have to measure the radius of an atom, radius of a electron, radius of an electron, radius of a proton. Like that, we have very small lengths also to measure. Now, in this particular topic, we will see how to measure different types of lengths. We all know how to measure various lengths. Generally, when we go to a clothes shop, when we purchase a cloth, we ask the cloth to measure in meters. We ask the shop people to give us 2 meters, 3 meters, 5 meters of cloth, like that. Now, to measure that, people in the shop, they use a meter scale. That meter scale that is used for lengths, 10 to the power of minus 3 meters, that is nothing but a millimeter, to 10 square, that is 100 meters. And if it is too small, if it is too small length, we can use a small scale and we can measure the length. The normal scale which we use in our geometry box, it measures up to 1 millimeter. What if the length is less than a millimeter? If you want to measure length less than a millimeter, what we should do? Which apparatus we have to take? For that, we have different types of uh, measuring instruments. Different types of measuring instruments. One such instrument is called as a vernier calipers. Vernier calipers is used for the lengths to an accuracy of 10 to the power of minus 4 meter. That means in a millimeter, 1/10 part it can measure. A vernier calipers can measure 1/10 of a millimeter. You can imagine how short or how small is a millimeter. Therefore, this vernier calipers measures 1/10 of a millimeter. And if you take other instruments, that is a screw gauge or a spirometer, they can measure the lengths as less as 10 to the power of minus 5 meters. It is still smaller than the measurement measured by the vernier calipers. 1/10 of a millimeter can be measured by vernier calipers. 1/100th part of a millimeter can be measured by a screw gauge or a spirometer. Like that, we have different instruments to measure smaller lengths also. And today's topic, I will tell you how to measure very large lengths, like the distance between Earth and Moon, distance between planets. Like that, we have different things to measure. And also, I will also explain how to measure even very small lengths, like the size of an atom. So, to measure the lengths beyond these ranges, like a measurement measured by a vernier calipers or a screw gauge or spirometer, we have to use some indirect methods. Now let us see what are these indirect methods. Now, first let us take the topic of measurement of large distances. That means imagine the distance between Earth and the Moon. Let us take the distance between Earth and the Moon. Just I gave you an example. This method can be used to find the distance of any planet or a star from the Earth, which cannot be measured directly with a meter scale. We cannot go to the moon by taking a meter scale, and we cannot measure the distance from Earth to the moon, isn't it? Nobody can take a rope or a meter scale and go to the moon to measure the distance of the moon from the Earth. Not only that, any planet from the Earth we cannot measure the distance of any planet from the Earth by taking a meter scale. In such cases, we have an important method called as Parallox method. Parallox method is a wonderful method which is used to measure the distance of any planet from the surface of the Earth. Let us assume capital D is the distance of a planet, S, from the surface of the Earth. Let us assume there is a planet, we have pointed it as S in the figure, and we want to find its distance, that is capital D, from the surface of the Earth. We want to measure the distance of a particular planet, S, from the surface of the Earth. Let us assume it is capital D. To find the distance, first we will stand at one point on the Earth, that is capital A. From there, we will see the planet. With the help of special type of telescopes or a binocular or some other optical instrument, you can find the angle SAB. Angle SAB. Okay? Then after that, we walk little distance away from A to a point B, and from there again we see the planet. Yes, first we see the planet from A, then we walk a little distance. That distance, let it be small b, and we will go to a point B, capital B, and from there again we see the planet. In simple words, first we stand at A and look at the planet S and measure the angle SAB. Again we walk to the point B. From B again we look at the planet and again we measure the angle SBA. SBA. Now you can imagine it like a triangle. In a triangle, the sum of the three angles is 180. Therefore, angle SAB plus angle SBA plus angle ASB is equal to 180. Now you have measured angle SAB. You have already measured angle SBA. Therefore, it is very easy to find angle ASB. Let us assume it as to be theta. Let us think angle ASB is equal to theta. So now we found the value of theta by taking the sum of the three angles in a triangle as 180. This angle theta is called as the parallax angle or parallactic angle. Since theta is very small, as small b is very much less than capital D, we approximately take AB as an arc of length of a circle. Of a circle means, I tell you, now the distance AB, the distance which we walked on the surface of the earth from the point A to the point B, let it be small b. But what is the distance when compared to the distance of moon from the surface of the earth? That distance is very small when compared to the distance between earth and a planet. Therefore, the small b, that is the distance between the 2 points A and B, it is too small when compared to capital D. Small b is the distance between A and B. A and B are the points from which we have observed the planet. Capital D is the distance of the planet from the surface of the Earth. So, when small b is very much less than capital D, we approximately take AB as an arc of length of an arc of length small b, of an arc of length small b. So AB we are taking as an arc of a length small b, and that small b is a arc of a circle. Then what will be the center of the circle? The center of the circle is at S. The center of the circle is at S. Now, now we know from the mathematics, angle is equal to arc by radius. Now in this, we can assume S is the center of a circle and yes, A is one radius, yes, B is another radius. Both are of same length, capital D. Distance between A and B is a small b, that is arc length. AB is the arc length, radius is capital D. Therefore, angle theta is equal to arc by radius. Therefore, theta is equal to small b by capital D. From this equation, you can find capital D is equal to b by theta. Capital D, that is the distance of a planet from the surface of the Earth, is equal to small b divided by theta, where small b is the distance between the 2 points A and B. A and B are the 2 points from which we observed a planet, like a moon. In this way, we can measure the very large distances. Once again, I tell you in simple words, take a planet, for example, moon, assume it at the position S, observe from a position A on the surface of the earth, walk little distance on the surface of the earth up to capital B, let AB is equal to small b. Imagine S as the center of a circle, small b as the arc of a circle, capital D is the radius of the circle, and we know the value of theta, then theta is equal to arc by radius, theta is equal to small b divided by capital D, therefore capital D is equal to small b divided by theta. In this way, we can measure the very large distances. Not only that, we can also measure the diameter of a planet. For example, if you want to measure the diameter of a planet, that can also be possible using this method. So now if you want to find the diameter of a planet, it is very easy to measure by using the known value of d, the distance between Earth and the planet. Already we found, just now we found capital D. Now, how to find the diameter of a planet? Imagine the diameter of a planet is xy, that is as shown in the figure. You can see the diameter of a planet is between the points x and y, which is small d. Now you stand at a position on the surface of the earth at the point z. Now only at you stand at a one point. In the previous case, we walked between 2 points, capital A and capital B. Now we stand at a single point z, and now we look at one side of the uh, planet, that is diametrically opposite points x and y we see. First we see x point and then we see the y point. That means, as shown in the figure, let us stand at a single point z on the surface of the earth and observe 2 points that are diametrically opposite on the planet, that is x and y. We can observe them using a telescope. Some special types of telescopes are available. We can observe them. Now, let us assume alpha is the angle between between these two positions which we have observed. That means alpha be the angle which we measure between these 2 points x and y from the point z. Let us see, let us measure the angle alpha. Then let us assume small d as the diameter of the planet and alpha is the angular size of the planet. Therefore, once again, like previous case, let us think small d as arc of a circle, z is the center of the circle, capital D, capital D is the radius, capital D is the radius of the circle. We will assume like that. Once again, I'm saying, let us assume we imagine a circle whose center is at z, whose radius is capital D, and small d is the arc of the circle. Then alpha is the angle between two radii, that is xz and yz. Now angle xzy, angle xzy is equal to alpha. Then alpha is equal to arc by radius. We imagine xy as an arc and the radius is capital D, arc is small d. Therefore, alpha is equal to arc by radius, alpha is equal to small d by capital D. What we want here, small d, because that is the diameter of the planet. Therefore, small d is equal to alpha into capital D, where capital T is the distance of the planet from the surface of the earth, which already we have measured just now. Now we have measured the diameter of the planet from the surface of the earth. Since alpha is measured and d is a known value, we can easily find the diameter of the planet, small d. We can easily find the diameter of the planet, small d. Now, how to measure very small distances? Just now we have seen how to measure very, very large distances. Now we will see how to measure very small distances. Very small means size of a molecule, size of an atom, size of an electron, size of a proton. So for that, special types of apparatus, equipment are available. We cannot measure a very small size like that of a molecule by ordinary methods like using a ordinary scale, meter scale or screw gauge or vernier calipers. We cannot use them to measure the size of a molecule. The size of a molecule will be generally 10 to the power of minus 8 meters to 10 to the power of minus 10 meters. An optical microscope also cannot resolve particles with sizes smaller than angstrom range. Angstrom means 10 to the power of minus 10 meters. 10 to the power of minus 10 means how much? 1 divided by 10 to the power of 10. Imagine how small it is. Imagine how small it is. Okay? 1 divided by 10 to the power of 10 meters. In such cases, even optical microscope also cannot measure them. Therefore, we have to use some special methods to find the size of a molecule. There is a simple method to find the size of a molecule that is called as oleic acid method. So that method, that is oleic acid method, is explained as I have shown in this particular topic. You can use this particular method to find the size of a oleic acid. Oleic acid is a soapy liquid with large molecule size of order of 10 to the power of minus 9 meters. Oleic acid is a soapy liquid with large molecular size of the order of 10 to the power of 10 to the power of minus 9 meters. That's called as a nanometer. So To find such a small size, we have to use some kind of method. So here we can see how we can do. The idea is to first form monomolecular layer of oleic acid on water surface. Monomolecular layer, what does it mean? Means if you spread oleic acid on the surface of the water, the thickness of that oleic acid should be as the size of the molecule. That's called as monomolecular layer. See, for example, if you put some drops of oil on the surface of water, you can see oil drops on the surface of the water clearly. Similarly, if you take water and on the water surface, if you put some drops of oleic acid, we should see that the thickness of that oleic acid on the surface of the water should be equal to the molecular size of the oleic acid. That is called as monomolecular layer. That is simple words. The thickness of that layer, which is on the top of a water surface, should be equal to the size of the molecule of the oleic acid. We dissolve 1 centimeter cube of oleic acid in alcohol to make a solution of 20 centimeter cube. So that means you can see the ratio. We take alcohol 20 times, but we take oleic acid one time. That is 1 is to 20 ratio. Then we take 1 centimeter cube of this solution and dilute it to 20 centimeter cube using alcohol. Listen carefully. First, we took 1 is to 20 ratio, that is oleic acid and alcohol. That means one part of oleic acid, 20 parts of alcohol. You formed one liquid. You formed one liquid. Take that liquid again. In that, the diluted liquid, you take again one part of the diluted liquid and then that and then take again 20 parts of alcohol, once again mix it. Then how much will be the concentration of the solution? 1 divided by 20 into 20 centimeter cube of oleic acid per centimeter cube of solution. That means, I tell you, first you took one, for example, 1 drop of folic acid, 20 drops of alcohol. You mixed it. You got a solution. Again, from that solution, 1 drop of that solution, again 20 drops of 1 drop of that solution, 20 drops of alcohol you will take. Again, you mix it. Then the solution is formed. First, you take 1 drop of oleic acid, 20 drops of alcohol. You get a solution. From that solution, you take again 1 drop of that solution, 20 drops of alcohol, again mix it. Then, how much will be the concentration of the solution? That will be 1 divided by 20 into 20 centimeter cube of oleic acid per centimeter cube of solution. Then what we do is we slightly sprinkle some lycopodium powder on the surface of the water in a large trough and we put 1 drop of this solution in the water. We take water in some big large trough and what we do on that, we sprinkle some lycopodium powder. Then on that surface, we put just 1 drop of this solution which we made with oleic acid and alcohol. The oleic acid drops spreads into a thin, large, and roughly circular film of molecular thickness on water surface. What happens now? The drop of a oleic acid solution, which we have put on the surface of the water, will roughly form a circular film. So just now I told you, like you can see oil drops on the surface of the water. They We can clearly see they will be in the circular form. In the same way, this oleic acid solution, you have put one drop on the top of the water, then it spreads into a thin circular, roughly circular film, and it will be a large one. What will be the thickness of this film? That means the thickness of that circular one, thickness of the circular one will be equal to the size of a molecule. The thickness of the layer, the thickness of the layer that is called as a film, that is equal to size of the molecule. Now, if you find the thickness of that solution, if you find the thickness of that layer, that is nothing but the size of the molecule. The water is there in a trough. On that, we have sprinkled some lycopodium powder, and we have put one drop of this solution, which we have made now with the oleic acid and alcohol. That drop spreads into a thin, large, roughly circular film. The thickness of that film will be equal to the size of a molecule. Now, if we can find the thickness of that layer, that is nothing but the size of the molecule. Then what we do? We first measure the diameter of this thin film to get the surface area of that film. That is the drop which we have put on the water, which is spreading. Which that drop we will take. We take the size of that circular drop, which is formed as a thin layer, that is called as a film. We measure the diameter of the thin film. Let it be capital A. So the thin film which is formed on the surface of the water, it is approximately like the shape of a circle. Then we measure the diameter of the thin film, and then we find the area. From the diameter, you can find the area of a circle. From the diameter, you find the radius. Radius is equal to half of the diameter, and area of the circle is pi r square. You will easily find area capital A. Now, if we have dropped n drops in the water, let us assume initially we determine approximately the volume of each drop. How many drops we have put, how many drops we have put, we will take into count, and we will measure the volume of one drop. For actually we have put one drop here. Before putting one drop, we will take some drops, like 5 drops or 6 drops, measure their volume, measure the volume of n drops. Then you can find the volume of one drop. So if you can find the volume of n drops, then if V is the volume of one drop, then for n drops it is n into V. Once again I repeat, if capital V is the volume of one drop, then 5 drops will have 5 into V. 6 drops will have 6 into V. And 7 drops will have 7 into V. In the same way, if one drop has a volume of V, then n drops will have a volume of n into V. Volume of n drops of solution is equal to nV centimeter cube. Therefore, amount of oleic acid in this solution, n into V divided by 20 into 20. We already have seen the part of oleic acid in this solution is 1 divided by 20 into 20. In such big volume, oleic acid will be 1 by 20 into 20, because first time we have taken 1 is to 20 ratio of oleic acid and alcohol. Again, we have taken that solution. Again, we have mixed with the alcohol. That is also 1 is to 20 ratio. Therefore, amount of oleic acid in this particular solution n into V divided by 20 into 20 centimeter cube. This solution of oleic acid spreads very fast on the surface of water and forms a very thin layer of thickness T. Already I told you the thickness is equal to the size of the molecule. If this spreads to form a film of area capital A, then the thickness is equal to volume divided by area. That's enough. We got the thickness of the film. So this solution of this folic acid, it spreads very easily and very fast on the surface of the water, and it has formed a thin layer. The we I already told you the thickness of that layer is nothing but the size of the molecule. So now we have to find the thickness. How to find the thickness? Cross sectional area, cross section, that is the area of the surface and the thickness, the area of the surface and the thickness is equal to volume, that is product of the area and the thickness is equal to volume. Product of area and thickness is equal to volume. Now you know the volume and you know the area. Now we have to find the thickness. To find the thickness, divide volume with area. We will get thickness of the film. So to find the thickness of the film, divide volume with area. Let small t be the thickness, therefore small t is equal to volume of the film divided by area of the film, or t is equal to n into v divided by 20 into 20 into capital A. NV 20 divided by 20 into 20, that is the volume. That volume is again divided by area, therefore capital A we see in the denominator. Volume is NV divided by 20 into 20. The volume is divided by area, therefore we see capital A in the denominator. Therefore small t is equal to NV divided by 20 into 20 into capital A centimeter. If we assume that the film has monomolecular thickness, then this becomes the size of the molecule of oleic acid. Already I told you many times the thickness of this layer is nothing but the size of the molecule of the oleic acid. It gives the diameter of the molecule of oleic acid. So that is the size of the molecule means diameter of the oleic acid. The value of this thickness comes out to be the order of 10 to the power of minus 9 meters. If you find the thickness, the value of this diameter of the molecule of the oleic acid is 10 to the power of minus 9 meter. It's called as a nanometer. Now you found a very small length, that is the size of a molecule using this method. We have seen how to find the large distances from the surface of the Earth to a planet by using Parallox method. We have also seen how to measure the small distances like the size of a molecule using this oleic acid method. So now let us see some range of lengths. The range of lengths change from very small things to very large things. Smallest thing like electron, proton, nucleus, atom, they are very, very small things. And the very large things are nothing but the whole universe. The sun, planets, all together form the universe. Therefore, very small thing, nucleus, is of the order of 10 to the power of minus 14 meters. And the size of the universe is of the order of 10 to the power of 26 meters. That is 10 to the power of minus 14 meters, which is that is nucleus of an atom. And the size of the universe is of the order of 10 to the power of 26 meters. Some lengths we have given for the past reference, which will be asked for 1 marks question, 1 mark question, 2 marks questions, which will be used for the numericals, which are very important. So we can see 1 Fermi is equal to 10 to the power of minus 15 meters. 1 angstrom is equal to 10 to the power of minus 10 meters. 1 astronomical unit is equal to 1 AU. It is written as capital A and capital U, that is equal to 1.496 into 10 to the power of 11 meters. That is nothing but average distance of the sun from the earth. Average distance of the sun from the earth. That is called as 1 astronomical unit. That is equal to 1.496 into 10 to the power of 11 meters. Then 1 light year is equal to 1 light year is equal to 9.46 into 10 to the power of 15 meters. What is 1 light year? The distance that the light travels with the velocity 3 into 10 to the power of 8 meters per second in 1 year. That means in 1 year, how much distance the light travels. We all know the speed of the light, 3 into 10 to the power of 8 meters per second. With that speed, in a year, how much distance light travels, that is called as light year. That is equal to 1 Ly is equal to 9.46 into 10 to the power of 15 meters. Another last one parsec is equal to 3 into, sorry, 1 parsec is equal to 3.08 into 10 to the power of 16 meters. 3.08 into 10 to the power of 16 meters. This is the distance at which average radius of Earth's orbit subtends an angle of 1 arc second. So these are the main things, distances, which will be used to for the numericals, which can be used for the numericals, or which can be also asked for 1 mark questions. So in this video, we have learned about measurement of lengths. I have explained you how to measure very large lengths uh, using Parallox method, how to measure very small lengths, and how to measure small lengths like one tenth of a millimeter, 1/100th of a millimeter using vernier calipers, screw gauge, etc., etc. And we have seen different types of methods and different types of scales, how to measure small distances, large distances, medium distances, etc. We have also seen different types of lengths like Fermi, angstrom, astronomical unit, light year, parsec, etc. With this, we can conclude our topic of uh, measurement of lengths. Let us meet with another video, how to measure the mass. Let us meet how to measure the mass in the next video. Thank you for watching this video. Thank you for watching this video. We will meet again in the next video with another topic, how to measure the mass, because length, mass and time are the main things which we have to discuss. With this, we can close our topic of measurement of length. Thank you for watching this video. See you all again in the next video. God bless you all.